Good morning to one and all. Today's topic is problems on differentiability of given functions. First question, show that the function f of x equal to x square minus 1 when x greater than or equal to 1, 1 minus x when x less than 1 has no derivative at x equal to 1. So once observe the question. Here f of x takes two values, that is x square minus 1 when x is greater than or equal to 1. This one we are going to use while finding f of 1 and RHD. Second value of f of x is 1 minus x. This is when x less than 1. This will be used while finding our LHD of given function. Now we want to show that this f of x has no derivative at x equal to 1. For this we want to find out LHD and RHD values. After finding if those two are not equal, then we can easily say that f of x has no derivative at x equal to 1. So solution, first of all we are going to find the value of f of 1. Observe, here x equal to 1 is there, that's why I am taking x square minus 1 while calculating f of 1. So replace x equal to 1. Here also 1 square is 1 minus 1. But we know that 1 minus 1 is 0. So f of 1 value is 0. Now we are going to find left hand derivative, that is LHD. LHD is denoted by L f dash of 1. The formula for LHD is limit x tends to 1 minus. Why I am taking here 1 means we want to check the differentiability at x equal to 1. That's why 1 minus f of x minus f of 1 by x minus 1. Here also why I am taking 1 means I am going to check differentiability of given function at x equal to 1. So now I am going to change x tends to 1 minus as h tends to 0 by replacing x by 1 minus h. So f of 1 minus h minus f of 1 as it is. X is replaced as 1 minus h, 1 minus h minus 1 as it is. So while calculating LHD we are using less than 1, that is f of x is 1 minus x. But here x is 1 minus h, that's why 1 minus 1 minus, actually this is the place of x, but here we have 1 minus h, that's why I am writing 1 minus h here. Once you can observe, if f of x is 1 minus x, then f of 1 minus h is just replace x with 1 minus h. That's why f of 1 minus h is equal to 1 minus 1 minus h. I already know the value of f of 1, that is 0. Denominator plus 1 and minus 1 get cancelled. The remaining term in the denominator is minus h. Here also multiply with minus sign. Minus into 1 is minus 1. Minus into minus h is plus h. Now in the numerator also cancel positive 1 with negative 1. Then we are going to get h as numerator. Denominator is minus h. Now h and h also get cancelled. Next we are going to get limit h tends to 0 minus 1. Limit of a constant is itself. Therefore, the value of LHD is minus 1. Now I am going to find RHD value. RHD means right hand derivative. It is denoted by RF dash of 1. The formula for RF dash of 1 is limit x tends to 1 plus f of x minus f of 1 by x minus 1. Now I am going to change the limit x tends to 1 plus as limit h tends to 0 by replacing x with 1 plus h. So x is replaced with 1 plus h minus f of 1 as it is. In the denominator also x is replaced with 1 plus h minus 1. While calculating RHD, we are going to consider the value of f of x as when x greater than 1. Here the value of f of x when x greater than 1 is x square minus 1. So we know f of x value, that is x square minus 1. So from this we can easily calculate f of 1 plus h as 1 plus h whole square minus 1. So f of 1 plus h value is 1 plus h whole square minus 1. At the starting itself we calculated f of 1 value, that is 0. In the denominator plus 1 and minus 1 get cancelled. So we are going to get h as denominator. Now in the numerator we have 1 plus h whole square. Now expand this term with the help of the formula a plus b whole square. This is a square plus b square plus 2ab. That means 2 into 1 into h. So 2h minus 1 as it is. Denominator h also I am going to write as it is. Now plus 1 cancel with minus 1. The remaining terms in the numerator are h square plus 2h divided by h as it is. Now I am taking h as common in the numerator, then h into 1h outside. That's why 1h we are going to get inside. Plus here we have 2h. If h is we are taking common, then we are going to get 2 here. If you want, you can multiply once again. H into h is h square plus 2 into h is 2h divided by h as it is. Now cancel h and h. Then we are going to get h plus 2 as the simplification of this step. Now I am going to substitute 0 in the place of h. So 0 plus 2 is 2. Therefore RHD value is 2. We already get LHD value as minus 1. Now the RHD value is 2. That means LHD not equal to RHD. Whenever LHD not equal to RHD, then we can say that f of h is not differentiable at x equal to 1. Now concentrate on second problem. Examine the differentiability of the function f of x. Here also f of x they given two functions x square. F of x value is x square if x less than or equal to 3. This f of x equal to x square we are going to use while finding f of 3 and LHD values. And also f of x equal to 6x minus 9 if x is greater than 3. This one we are going to use while finding RHD. Solution is as follows. First of all, I am going to find f of 3 value. F of 3 means replace x with 3. So, f of 3 equal to 3 square. 3 square is 9. Now, I am going to find LHD value at x equal to 3. Therefore, f dash of 3 equal to limit x tends to 3 minus f of x minus f of 3 by x minus 3. Now I am going to change the limit x tends to 3 minus as limit h tends to 0 by replacing x by 3 minus h. So, numerator becomes f of 3 minus h minus f of 3 divided by denominator is 3 minus h minus 3. So, now f of 3 minus h value is, here we have f of x value as x square. That's why f of 3 minus h value is 3 minus h whole square. So, replace f of 3 minus h by 3 minus h whole square. Already we know f of 3 value, that is 9. Observe the denominator. Here we have positive 3 and also negative 3. So, cancel 3 and negative 3. Then we are going to get minus h in the denominator. Now, we are going to expand 3 minus h whole square by using the formula a minus b whole square. A square, that is 3 square, 9 plus b square, that means h square minus 2ab. 2ab means 2 into 3 into h, that is 6h. So, a square plus b square minus 2ab minus 9 as it is, minus h is also as it is. Now, observe the numerator. In the numerator, we have positive 9 and negative 9. So, cancel those two terms. Then, we are going to get h square minus 6h. In that, h is common. So, take h common. After taking h common, we are going to get h only here, because h into h is h square minus, here we have 6h, h is common, that's why we are going to get 6 here. If you have any doubt, once again multiply, then we are going to get h square minus 6h divided by minus h as it is. Now h get cancelled, then we are going to get limit h tends to 0 minus h minus 6. In this expression, I am going to substitute h equal to 0. So, minus of 0 minus 6. 0 minus 6 is minus 6. So, minus 6 into minus is plus 6. Therefore, the value of LHD is 6. Now, I am going to find RHD, that is right hand derivative at x equal to 3. That is denoted by R f dash of 3. This is the expression for RHD. Here we are going to find RHD at x equal to 3. That's why we are writing here 3 plus and also here f of 3 in the denominator also 3. Now observe f of x value is 6x minus 9. So f of x value is 6x minus 9. Then f of 3 plus h is 6 into 3 plus h minus 9. So 6 3s are 18 plus 6h minus 9. Why I am finding 3 plus h f of 3 plus h means here I am going to change limit x tends to 3 plus to limit h tends to 0. So x is replaced with 3 plus h in the numerator as well as in the denominator. Now I know the value of f of 3 plus h. Substitute that value minus f of 3 already we know, that is 9. Observe 6 3s are 18. 6 into h is 6h. Minus 9 is minus 18. Divided by h as it is. Observe the numerator. Here we have positive 18. Here we have negative 18. Cancel those two, 18 and minus 18. Then we are going to get 6h by h. Now h and h cancel. Then we are going to get 6. That means limit h tends to 0, 6. 6 means constant. Limit of a constant is constant itself. That's why LHD is 6, RHD is 6. Then we can easily say that LHD equal to RHD at x equal to 3. Therefore, f of x is differentiable at x equal to 3. Next question. Example 3. Examine the differentiability of the function f of x equal to x square into sine 1 by x if x not equal to 0 and f of x equal to 0 if x equal to 0. That means whenever x equal to 0, f of 0 is 0. This can be used while calculating LHD and RHD. Now we want to examine the differentiability of given function at x equal to 0. Consider LHD, that means left hand derivative, equal to L f dash of 0. Why 0 means? Now here we want to find out differentiability of given function at x equal to 0. Equal to limit x tends to 0 minus f of x minus f of 0 by x minus 0. This is the formula to find LHD at x equal to 0. Now I am going to change limit x tends to 0 minus into limit h tends to 0 by replacing x in the numerator and denominator by 0 minus h. So, numerator becomes f of 0 minus h minus f of 0 divided by 0 minus h minus 0. Observe in the previous two problems f of x having two values. One is when x is less than 1, other one is when x is greater than 1. But in this problem f of x having only one value, that is x square into sine 1 by x. So f of 0 minus h is equal to 0 minus h whole square sine 1 by 0 minus h. We already know the value of f of 0 is 0. 0 minus h is minus h whole square is h square. Here sine of 1 by minus h. Observe all of you. Sine of 1 by 0 minus h is minus h. We know that sine of minus theta as minus sine theta. So, we are going to get sine of 1 by minus h as minus sine of 1 by h. So, this minus sign I am going to write here. Finally, the simplification of numerator is minus h square sine of 1 by h. Denominator minus h as it is. Now, minus get cancelled, 1h get cancelled. Then finally we get limit h tends to 0, h into sine 1 by h. In this expression, I am going to substitute h equal to 0. So, here we have h. So, 0 into this is angle. That's why but we know the value of limit h tends to 0 sine 1 by h is a finite quantity between minus 1 and 1, because the sign range is minus 1 and between minus 1 and 1. 0 into a finite quantity between minus 1 and 1 means 0 itself. That's why LHD value is 0. Now RHD value. RHD equal to R f dash of 0. This is the expression to find RHD value at x equal to 0. Now I am changing this limit x tends to 0 plus into limit h tends to 0 by replacing x by 0 plus h in both numerator and denominator. After replacing x by 0 plus h, we are going to get this expression. So, 0 plus h whole square, y means we have f of x value as x square into sine 1 by x. So, x means 0 plus h whole square sine 1 by 0 plus h minus f of 0 is 0. f of 0 equal to 0 is given value. 0 plus h is h square sine 1 by h. Denominator already we have h. 1h cancel. So finally we get limit h tends to 0, h into sine 1 by h. Substitute the limit. So 0 into, observe, we have limit h tends to 0, h into sine 1 by h. This can be written as limit h tends to 0 h into limit h tends to 0 1 by h. Here I am going to substitute 0 directly. So 0 into a finite value between minus 1 and 1. So 0 into a finite quantity between minus 1 and plus 1 means 0 itself. So LHD 0, RHD 0, that's why these two values are equal. Whenever LHD and RHD are equal, we can easily say that f of x is differentiable and the derivative value is LHD value or RHD value because both are equal. In this case, f dash of 0 is 0. Y means LHD 0, RHD 0.